Okay, let's venture over to physics for a minute. So, should be noted that physics people, for some reason that I do not understand at all, use dots instead of primes. I think it's because they like hard typesetting. I don't know. They do. It's weird. I don't know. I think it's really because they couldn't find the apostrophe key on the keyboard, so they decided to define a macro where it just piles dots on top of letters. Not sure. So anyway, in real people notation, that would be P double prime minus 9.8.
Minus G.
Oh, but now you're using like Newtonian notation. I thought you were a mathematician, Joe.
Oh,
Wait,
Where's your Euclidean stuff?
okay, anyway.
You inspired to follow the arc.
You mean my Leibniz notation?
Yeah.
Is that what you're complaining about?
It's like deep
Okay.
DT.
9.8.
I'm good. I'm good with the primes in here. They're going to simplify things a lot. So this is acceleration due to gravity, right?
Almost.
Yes?
Squared 2, yeah.
At basically sea level or something. I forget where the 9.8 applies.
It's at sea level with normal atmospheric pressure.
Cool.
And temperature.
All right. So I would like to solve what's going to be called an IVP, or an initial value problem. So there are going to be a couple things given to me. So a couple more pieces of information are that P of 0 is 300 and P prime at 0 is 0. So can anybody describe to me the physical situation in which this differential equation occurs?
A ball is dropped at 300 units up and it doesn't move in the beginning.
Yeah, so this is let go of an object, 300 watts. It's not units. The units are baked into this.
Meters.
Meters.
Oh, damn.
Why are the units baked in?
For real.
How did I?
Chris, why are the units baked in now that you've been embarrassed?
Because it's 9.8 meters per second per second.
Okay, because the 9.8 only applies in the case of meters and seconds, right? Otherwise it's different. So, how do you solve an equation like this?
So you're going to take the, you're going
Do what
to
you want.
integrate the one, and then you're going to maybe kind of solve for a constant.
You gotta name it.
Good. Nice, Gabe. So first name it. So this is a second order
Ordinary.
differential equation with
Initial condition.
initial conditions. So these things are called initial conditions. And Katie's right, the way we solve it is you slap an integral.
Multiply by s.
Yeah, throw the big squiggle on there. Did I tell you guys about D-eaters?
Yeah.
I had a buddy in graduate school whose dad was an engineer for one of the mines in Butte, and his understanding of calculus was perfect for what he needed, but it was that this thing's a D-eater. It just eats the D off the equation. And shit, if it doesn't work, like, works fine. So you need to eat the D off of this thing. So you get out of this. After you eat one of the D's off of P double prime, what do you got? You got P prime. You got P prime is minus 9.8 T
Yeah, because we're one T.
plus
A constant,
a constant.
because we're working over in T product.
Yeah, so why T?
Yeah.
Physics.
Physics. Right, it stands for time in this case. Oftentimes, you're going to get a differential equation and the independent variable's name is not going to be told you. It's going to happen a lot.
Something.
Yeah. So earlier I did a population model where I ended up with x's in the end. Is that the best choice? Probably not.
Well, if you're in Texas, then it's fine.
Oh my gosh.
Okay.
That joke is it's dead.
Okay, constant at the end, right? So this is a function of p prime. Wait, this is a function p prime. What am I suppressing here? This is really p prime as a function of t, right?
Oh,
You see that? So, how do you get to the next step? What's your next step?
Do it again.
Therapy.
Integrate again. So you integrate p prime dt, and you need to integrate all this jazz.
You get two different constants.
So, little calc 2 should get you to p is
Negative
G t
9.8
squared.
t squared, yes,
negative 9.8 t squared over 2
plus ct
plus ct
plus c.
plus c?
Or,
Two numbers is a number. The number is 300.
I like to put a constant with respect to p prime and a constant with respect to p.
It just is.
Okay, yeah, so you could put a constant p prime and constant p. I'd probably just do 1 and 2 myself, but whatever.
It's not complicated enough. You need superscripts for your subscripts.
remember, this is specific. Sorry.
Yeah, so if this was like in physics land, C1 wouldn't be C1, it would be
B not.
V naught, and C2 would be
S not.
Or
P-
D.
naught, maybe?
S not.
So the reason for that, right, is that here's your equation for P prime, here's your equation for P double prime, and here's your equation for P, right? I got my 3 equations? But then you know a little more stuff. What is the little more stuff you know?
300.
Yeah, you know that
It just
P of
is.
0 is 300 and P prime at 0 is 0.
So knowing that the equation we just found is actually P of t equals all that stuff, we can then.
So if you take this guy, right, your P prime,
Zero.
and leverage your P prime at 0 is 0, you get 0 is minus 9.8 t plus, oops,
4.9.
minus 9.8, what?
Oh, P.
T or whatever.
Isn't it? No.
So this tells you t is 0, right?
Oh, 0 equals 0. Yeah.
And then so that means you see.
So minus 9.8 times 0 plus my first constant, right? You see that? So C1 0.
Which doesn't factor in this line.
Bam.
So that part's gone. And then you can also leverage your P of 0 is 300. Right? So when P of 0, no, sorry, when T is 0, P is 300. So 300 is minus 9.8 times 0 squared over 2 plus C2. You see that? Yeah, so you get C2 is 300. So all told, at the end here you get one solution, and it's P as a function of T is minus 4.9 T squared plus 300. All good with this? Questions still?
Do we have to do what you did where you solved it at the end, because if we find each one?
No, it's probably a better idea, right? If you have the initial conditions, leverage them as you get them.
Because then it's easier to see.
Right, so right here you've got P prime of T is minus 9.8 T plus C1, right? Well, you know that P prime at 0 is 0. So 0 should be C1. Drop it. Don't integrate it. You guys see that? So I don't care when you do that. You can do it either kind of as you go or at the end. Sometimes, in some of the techniques, you'll have to do it at the end, because you'll kind of find things together. There's a couple techniques where everything gets all tangled up and you just kind of get it all in a wad at the end. But in these techniques, if your procedure allows, you should use them as you go. It's cool, that? Okay. What's this good for?
dropping stuff off of stuff.
Yeah, I use this occasionally when we get to the top of a cliff and I wanna know if my rope reaches.
When you're really
If
small.
you take a
it's-
rock and drop it, count. 1, 2, 3, you can hear it when it hits, right? And then whatever you get, you square it, you multiply by 5, and that's how tall the cliff is in meters.
Squared multiplied by 5?
Yep.
That's freaking cool.
Wait, how do you multiply by 5?
Because multiplying by 5 is easier in my head than multiplying by 4.9.
Ah. Gotcha. Makes sense.
Plus, I'm kind of ballparking seconds by
right.
dropping this anyway, right? The other cool thing is you don't have to drop it straight off.
Right.
You can throw it as long as you throw it flat. Right, because the horizontal velocity
Right.
doesn't factor
You can't
into this,
do
it's
that.
only a vertical velocity.
It's kind of hard to do that though. Have a perfect 0-degree angle.
I mean, it's only gotta be
I feel like
close,
I was
you're already
definitely down in the
counting.
beginning.
Questions, things?
If you
You
make
good with
p
this?
prime of 0 equal to a positive number, then that would imply it going up first. You're tossing up a little bit, right?
So the P prime, yeah, so this is the initial velocity, right? In meters per second,
So if you
vertically.
shot something,
Yeah, this is only.
Yeah, so if you point a pistol upwards, right, it's gonna have an initial velocity upwards. The position's gonna remain whatever it is, right? You can see that? And then what'll happen, right, is the acceleration due to gravity will drain off your initial velocity.
These are axes assuming that gravity is pointing downwards.
Yeah, this whole thing is built to assume that gravity points downward, and the only thing I care about is the vertical position of an object. If you care about more than that, you need to write down more equations.
So, is total mechanical energy going to end up being like some sort of differential equation?
Yeah, a whole bunch of things are, yeah, a whole bunch of physics things are all differential equations in one form or another. Cool? Okay.